Welcome back to part 2 of question 10. So in the first part, as a recap, we discovered that velocity was a function of time, starting from this point here. And in part B, we've been asked to express acceleration as a function of time. So for this one, we will note that the definition of acceleration is the derivative of velocity with respect to time. And so that means we need to take the time derivative of this expression here, 30 e to the t minus 1 over e to the t plus 1. 30 is a constant, so we can bring that to the front, and our task is then the derivative of e to the t minus 1 over e to the t plus 1. This is a quotient, so remembering the quotient rule, as a recap, the quotient rule, we would have, there's 30, and then we'll apply the quotient rule. It's the denominator, e to the t plus 1, multiplied by the derivative of the numerator, which is in this case is e to the t, minus the numerator, e to the t minus 1, multiplied by the derivative of the denominator, e to the t, all divided by the denominator squared, e to the t plus 1 squared. So expanding this, we would have e to the t times e to the t is e to the 2t plus e to the t. Now think of this as negative e to the t times this, so it's minus e to the 2t, and that times that is plus e to the t over e to the t plus 1 squared. These terms are equal and opposite. So I have 30, now e to the t plus e to the t is 2 e to the t, so that is 60 e to the t over e to the t plus 1 squared. That's the acceleration expressed as a function of time. And that's the end of part B.